In 2006, 80 deer were introduced into a wildlife refuge. By 2012, the population had grown to 180 deer. The population was growing exponentially. Write an algebraic function n of t representing the population n of deer over time t. So this is telling us to write an algebraic function n of t. That just means write an equation. And since this is growing exponentially, we use our exponential growth formula. In this formula, a is the initial value, or where it started, and b is our growth factor. Of course, x is our variable. Okay, so let's go back to the problem. Instead of f of x, we're going to have n of t, so we know what goes here. And we also know that in 06, there were 80 deer that were introduced. So it looks like 80 may be our starting point, or our A. But let's keep reading and see what we have. We know that N is the population of deer, and we know that time is our T. We need to somehow define T though. Since this whole situation started in 06, why don't we let T be the number of years since 2006? If we do that, then 06 represents when T is 0, right? So when T is 0, the population is 80. Let me make a little note of that. When T is 0, the population is 80. So this is what our ordered pair looks like. Well, then what is our other ordered pair then? We know that in 2012, which is 6 years later, right? In 2012, 6 years later, the population was 180. So we do have some information to work with. Well, let's see how all of this fits into our formula. We have n of t is equal to a, which is our starting point, right? B to the t. Instead of x, we have a t. So how do we figure out all these other little bits and pieces? Well, according to this is our population. And this is our time. Don't we have a population and a time in the second ordered pair? So our population is 180 and our time is 6. Well, let's solve this. We're going to divide both sides by 80. So we have 180 divided by 80 is 2.25. Now if this comes out to be some crazy ugly number, don't round it. Never round any number until you get to the end of the problem. So you could store it, like a store X, enter, something like that. You could store it, or actually that's probably the best way to go, is to store it. This one's okay though, it's just 2.25, so we can leave it like that. Now how do we get rid of the 6th power? We're actually going to have to take the 6th root, right? Or raise it to the 1/6 power. That's the same thing as taking the 6th root. So if we have 2.25 to the 1/6 power, I just stored that in x. So I'm just going to do x to the 1/6 power. And I get this crazy number. So we have reached the end of looking for b. That means we're going to round it. For this problem and all other problems in this section, once you get to what you're looking for, you round it to 4 decimal places. Okay, so we have 1.447. This is going to be our growth factor. Now we can place everything into our formula. N of t is equal to the initial amount times b to the 1.447.